Good morning, everyone. This is another day, and today we are going to attempt to run through section 10.4 in your book. It's dealing with inscribed angles. Um, this actually kind of represents the halfway point in your textbook, um, and we're going to get through this, and we'll in another couple days. I guess that would be on Monday. We'll cover 10.5, and sometime, hopefully, not next week, but early to the middle of the week after, we'll have a test on chapter 10. So hopefully we can get through this chapter here in another little bit, maybe a week and a half. Okay, so let's go through some stuff. By the way, first of all, again, let me remind you, if you have not yet signed up for Khan Academy, please do so. Also, I think I mentioned it the other day, but I'm going to do so again. If you have signed up for Khan Academy, but your display name is some sort of really strange username, if you will please go into your account settings and change your display name so that it displays it as your actual name, which is given in iNow, so that when I'm kind of trying to determine who has done what, I know how to assign it to you. Some of you have signed up for it as your S numbers, and you have to remember, not only am I not the teacher in the classroom, I'm your virtual teacher basically. Uh, I do not know who you all are. Okay, so I really need your help in getting those display names fixed, so that I have the ability to make sure that when you do the work, it gets assigned to you, right? So that you get the credit for the work you've done. Okay, so putting that out there, put it in your planner, write it on your arm, whatever it takes so that you can remember that when you get home, okay? All right, let's talk about some terminology, a couple definitions that we need to get through for this unit, or for this one little, lesson. And that is an inscribed angle and an intercepted arc. Okay, these two things are related. So, an inscribed angle is an angle that has a vertex, like this angle R over here, on the side of the circle, okay, and on the edge of the circle, and then its sides are chords of the circle. So what we want is we want the vertex to be here, and then we want the sides to be these chords. Okay, so that angle QRS is an inscribed angle. Okay, and an inscribed angle creates what is called an intercepted arc. So in that same circle, that the fact that we have this arc right here, QS, where its endpoints are located where the sides of the circle, or sides of the angle hit the circle, that makes what is called an intercepted arc. So in our case, arc QS is an intercepted arc. Okay? So it's got to be lying in the interior of that inscribed angle. Okay, and then lastly but not least, we have this way to figure out the measure of the angle if I know the intercepted measure of the arc, or the measure of the arc if I know the angle. So basically, in this case, just like our example for our circle, that angle, that measure of that angle QRS is equal to 1/2 the measure, in our case, of the arc QS. Okay, so this is going to be really important. We're going to be able to basically, if you're given the arc, I'm going to be able to find the angle. If I'm given the angle, I'm going to be able to find the arc. Okay, got a few more little theorems to run through, just like all geometry chapters, lots of theorems and definitions. All right, again, like I said, I hope you've been reviewing these to make sure you can hold on to them. This one says if I have two inscribed angles of a circle and they intersect the same arc or congruent arcs, then those angles are congruent, okay? This is going to be really useful to me. So, if I have this circle here, and in this circle, right, I end up with one angle here and one angle there, and they intercept that same piece of the arc over here on the side, right? Then that means that those two angles are congruent angles. And it makes sense, right? I would have used the same arc, that formula that I just had on the last page. I've used that same formula to be able to find the measurement of the angles. And since the arc is the same measurement, then the angles must also be the same measurement, okay? So this is theorem 10.7. Next two have to deal with either inscribed triangles or inscribed quadrilaterals. For a triangle, all right, if the inscribed angle of a triangle intercepts a diagonal, intercepts a diameter of or semicircle, if that angle is a right angle. So in this case, angle G, okay, is equal, the measure of that is equal to 90 degrees. All right. In the quadrilateral, what we have is if we've got this quadrilateral inscribed inside of a circle, then what we've found out is that the opposite angles are supplementary. So in our case, angle L plus the measurement of angle N are going to equal 180 degrees. All right, just like the measurement of angle M and the measurement of angle K are also going to add up to 180 degrees. Okay, these things are going to be supplementary. All right, so that's the information we need in this chapter, or this section, excuse me. And so let's go look at some examples. All right, so I'm given this circle right here. Let's make it a little bit bigger. So I want to find both the angle P and the measurement of the arc PO. So first thing I notice, if I want to find the measurement of angle P, I notice the angle P, right, is an inscribed angle. So I have this inscribed angle, and I would like to figure out what that measurement is. And I know the measurement of the arc. And I remember that it told me that the measurement of my angle, all right, is going to be, the measurement of angle P is going to be equal to 1/2 the measurement of that arc that's intercepted. So in our case, measurement of angle P is 35 degrees. All right, the arc. Same thing goes. Again, PO is right here. That is an intercepted arc. Here's the inscribed angle that makes that arc. They say that that angle is 56 degrees. If that angle is 56 degrees, then that means the measurement, that 56 degrees is going to be equal to 1/2 the measurement of my arc. So that means the measurement of my arc, PO, is going to be what happens when I multiply this thing by 2, or 112 degrees. Okay, so that gives me a really quick, simple, easy example to go through. Let's deal with the next example. I've got this angle S, and I've got this that I know is 3x, and I've got the, I want to find measurement of angle T. That's the first thing. That's up here. So angle T is right here, right up here. And I noticed that angle T is dealing with this angle. And then I noticed, hey, look, there's another angle that intercepts that same arc. So that means that those two angles must be the same. They're both given values with x in them. So in this case, that means that 3x minus 5 must equal 2x plus 15. Right? Those two angles must be the same. We have that theorem back here that said, right, that if they intercept the same arc or congruent arcs, then their angles are congruent. So these angles must be congruent. So I'm going to subtract 2x, I'll get x. And when I add 5, I get 20. So x is going to be worth 20. That's the value of x. So to find the angle T, the measurement of that angle, measurement of angle T is going to be equal to 3 times 20 plus 5 degrees, or 65 degrees. Alright, next, angle S. If I know angle S is 3x, and I know that angle V is x plus 16, I'd like to find the measurement of angle S. So again, here we are. Angle S. Okay, let me do this with the highlighter. Maybe the green. Angle S is dealing with this inscribed angle. Angle V is dealing with that inscribed angle. They both intercept the same arc TU. That means they must be congruent. That means that 3x must equal x plus 16. Therefore, 2x must equal 16, where x must be equal to 8. Alright, feels good, right? Feeling good about our life. Oh boy, oh no. Oh, the worst thing that could ever happen in geometry has happened, is asking about a 2-column proof. Please, please, save me now. Alright, if I want to find out how to prove this thing, I want to set this up. I want to go nice and slow. There's actually lots of ways to prove this. I'm just going to go through one of the possible ways. Okay? So the first thing we should always do on a 2-column proof is have, that's right, 2 columns. Okay? And the first thing I'm going to say is that arc JM is congruent to arc KL. By the way, this is like the first proof I've had to do since I was in, well, since the last time I taught geometry, which would have been like 2010. So, it's been a while. Alright, so forgive any rustiness here. So this is the given statement. This is the one that we all get, right? Everyone gets the given statement, alright? Yay for that. Now I've got to figure out how I'm going to get to figuring out these angles are congruent. So we've done a whole lot of chapters on congruent triangles. Right now, I just know that this arc and this arc are the same, right? And that those two values happen to be the same. Since I know that's true, I remember in an earlier section in this chapter, that means that the chords, right, that have that arc as its endpoints, that those chords must be congruent. Therefore, I know that JM, the line segment, must be congruent to KL, the line segment. Why? Because congruent arcs have, man, that's really hard to type or to write on here. Let me erase this real quick, because I realize nobody can read that. So let me see if I can just type this in real quick. Okay, this is because congruent arcs have congruent minor chords. Okay, that was a theorem that we had earlier. So now let's see what else we can do. So now I know basically this is good because what this has been able to give me is that I now know that that is congruent to that. So I now have that a side is congruent. Okay. The next thing I'm going to go for is I'm going to say that angle J and let's see, and angle K intercept the arc LM. Okay, and I can get to this so that those two angles intercept arc LM, and I can get to this because this is the definition of a intercepted arc. Okay. In fact, I would have added into this on the same spot, but I kind of ran out of room here. Well, I guess I can scroll down. I would have added into that same spot that angle. Let me scroll up and see it. Angles M and angles N. These two angles right here also intercept arc JK. So let's see. That was L and M. Angle L and angle M intercept arc JK by that same definition. Okay, so that's nice, right? And then I'm going to use, now that I've got that, I've defined these things as intercepted arcs. And in fact, I've not only defined that, I've defined that some of these angles intercept the same arc. Remember, we now have a theorem that states, and I'm just going to kind of finish it up over here. We have one that states that if they intersect the same arc, then those angles must be congruent. So that I know basically that L angle M and angle L are congruent. Excuse me, I should write that as congruent. Angle M is congruent to angle L. Why are those two things congruent? They intercept the same arc. Okay. Angles that intercept the same. I'm gonna write that over here. Hold on. I'm coming. Hold on. Alright, angles that intercept the same arc are congruent. And by the way, I'm going to use this same logic to get the fact that those other two angles that intersect the same arc are also congruent. That would be angles J and angles K. Okay, same reason. So now what I've got here is that these two are congruent and these two are congruent, which basically what that gives me now is angle side angle congruency. Okay, so that now I can say that, and I'm going to scroll down just a little bit, that a triangle JMN is congruent to triangle KLN by angle side angle congruency. Okay, boy, that was fun. I haven't done a proof in a really long time, so that let me use my brain. That was fun. All right, let me say something while I'm in here. Tell this to my students all the time. If it's not something you have to work to do, then it is not something that's going to be a skill that is going to help you kind of make more money, as a future employee somewhere. We want to have skills that are hard to do, things that are difficult, things that make us work. Why? because those kinds of skills are the skills that pay. Okay? Nobody pays you a lot of money to do things that everybody can do easily. Okay? So proofs are hard. Yes, they can be difficult. But what I want you to know is they are something you want to work at, because being able to understand the logic of that is what's going to be able to help you be more successful. Alright, so let's continue on. Example number 4. In example number 4, we've got a triangle inscribed inside of our circle. And this triangle, we were trying to find the measurement of angle F. So this is the angle I'd like to find here. Well, that's designated by this 4x plus 2 business. And they've also given me kind of some information about angle H, but nothing obviously about angle G. So let's see if we can think about this. Angle G, which is right here, okay, what's true about that is it is a inscribed angle, and the chord that makes this thing up right here is a semicircle, or a diameter, excuse me. So what this tells me is that that angle G, by that theorem we had earlier, must be 90 degrees. And if you're wondering how they got to this, remember, the angle measurement is half the measurement of the arc. And the measurement of an arc, if it's a semicircle, is 180 degrees, which is half of the circle. So that means the angle must be 90 degrees. Now that I know that, I know something about all three angles. And whenever I know something about all three angles in a triangle, I should be able to solve it, because I know all three angles add up to 180. So I know that I've got 4x plus 2 plus 9x minus 3 plus 90 degrees needs to equal 180 degrees. If I subtract that 90 over, that'll give me 90 degrees over here. And 9x plus 4x is 13x. 2 minus 3 is negative 1. So 13x. 13x minus 1 is equal to 90. Which would be that 13x is equal to 91. And therefore, I can divide this by 13. X is going to equal 91 divided by 13, which, let's see, is 7. Alright, now that I know that x is 7, I can find the angle F. Angle F up here is 4x plus 2, so that means to me that angle F is going to be equal to 4 times 7 plus 2, or 30 degrees. Alright, example 5. The good old, like, let's pretend that we can make this some sort of real world application problem. Here it is. I have a necklace with a charm that looks like a kite on the inside. I want to find the measurement of angle A, which I don't see shown on here. I think it just got cut off. It should be over here. And I also want to find the measurement of angle B. So let's look about angle A first. Remember, what I know about a quadrilateral is the angles in the quadrilateral must be supplementary. Angle C, right over here, if you can't tell, that's got a little right angle mark in it, so that one is 90 degrees. So that means if that's 90 degrees, then that means angle A must also be 90 degrees, because they need to add up to 180. To figure out angle B, I'm going to need to use the fact that this is x and this is 2x minus 30. Those two things must add to equal 180. So x plus 2x minus 30 is equal to 180. So 3x, if I add the 30 to the other side, is going to be equal to 210, or x is going to be equal to 70. Once I know that x is equal to 70, I can figure out what angle B is. The measurement of angle B is 2 times that 70 degrees plus 30. Minus 30. Which is 140 minus 30, which is a 110. Alright, so that gets us through this section on inscribed angles. I recommend you practice some problems out of the book, try the odd ones, use the ones that are on hot math so you can look at it. And again, let me remind you that you needed to have signed up for Khan Academy if you have not already. And congratulations on making it halfway through the chapter. See you next time, guys.